All right. And so sort of to guide this presentation, say why are we doing Spack CI? It's to generate build caches. The caveats that we want them to be trusted binaries, tested and curated. And then underneath all that, we want to have a scalable and stable infrastructure. And so starting with trusted, just a little overview of what's in a build cache. So every build cache entry for a concrete spec is composed of two components. The first is the binary archive. So this is the tarred and zipped install tree. This includes the .spack information, which has some stuff in there that's not reproducible, and so hashes can change between, so that'll be important later. And then the other part is the metadata. So this is the concrete spec that's serialized, as well as metadata about the binary archive that's stored. And so in version v0, we had a tarball of a tarball. And so the install archive, as well as all the metadata, was inside of one single tarball. This was great. We could write things, and everything was wonderful, except for zip bombs and arbitrary code execution and other vulnerabilities associated with extracting unverified tarballs. So we had to fix that. V1 and 2. We solved the extracting unverified archives. Hooray, but we lost idempotent writes and reads to the build cache. And so you could have multiple writers, and you would have hashes that disagreed between the metadata and the archive. So that's kind of sad face. So what are we going to do about that? We're going to fix it forever with the build cache layout v3. This got merged yesterday, very exciting. And so this splits the metadata up a little bit more into manifest and blobs. And so we have a manifest that describes the content hash of the install archive, as well as the content hash of the serialized spec. And then from that manifest, we can point to the blobs in the blob store. And so the manifest itself is signed, except for indices. There's some reasons for that, but we'll not go into that too much here. So talking about signing, we use two sets of keys for signing binaries in Spack CI. So the first set of keys, or the GPG keys, are intermediate keys. And so these are keys that are associated with the groups of runners that are doing the builds in CI. And so these are the keys we mount onto the builders. Once we're done, we sign the binaries and push them up. Once all of the builds are done, we have a second key. This is the reputational key. It's protected by, quote unquote, the guys with guns, and is not exposed to build jobs, and is only run on very specific privileged runners away from all of the builds. And so that's how we sort of protect it from being exposed. But this is convenient because now you only need one key in order to verify binaries in the build cache. And we're looking at different types of signing that we can do. So one is cosign. This is kind of nice. We can still do the intermediate reputational key signing paradigm. It's also compatible with OCI build caches. So right now, OCI doesn't support signing because you can't just inject GPG keys into JSON there. And then it also has a transparency log, which is nice for auditability. And then in that conversation, we also talked about switching from a clear sign to detached GPG signatures. So this would normalize signing across them, would also allow us to support signing in OCI, preserve artifacts from the intermediate signing stage after we re-sign with reputational, that sort of thing. So tested. We do testing if the package provides it. If it doesn't provide it, then we can't. And we don't require the tests to pass because they can't always pass. And so we run that after we push the binaries. The binaries are getting into the build cache is the priority. So what do we do about that? We track it. So we have a C- dashboard, and this tracks all of the tests that run and associate them with the binary hashes that were built. And so even though they aren't necessarily passing, we can at least look and see what the state of that is. So another issue with testing right now is you build and test on the same node, which means if you have a GPU enabled package, you want to build that, you have to be on a GPU enabled node. And so what we want to do is we want to split this into 2 jobs so we can build on a CPU node that's much cheaper, and then keep those GPU resources for those GPU enabled tests. And an issue with that, we actually spend about 1/4 of all time in CI downloading from the build cache. And so we kind of want to solve that before we add another job that will, once again, download everything from the build cache. And so binary curation is basically stacks. So the first stack was very small and is lost to time and a GitLab that no longer exists. We think that it was CMake, probably VTK, very similar to the Windows Viz stack that we use for Windows CI now. It was triggered externally. No, it was named E4S in the configs, yeah, and yeah.
It was the whole package list. Okay.
So this was back in like 2018. So we wanted to bring these stacks into Spack and sort of keep them close to the code that's changing. And so we came up with a new module in Spack called Spack CI, which split into a generate and build phases. So generate will concretize an environment that defines the stack, translate the DAG of the concretized environment to a pipeline, and push that as an artifact, which gets picked up by a trigger job for build, which spawns all of the builds in CI. So this is pretty cool. You can see fanning out in the stages there. So we went from 1 to 27 stacks. We do about 2,000 builds per week. It's quite a lot. You see, though, we have some duplication in target audiences. So these ML stacks are very, very similar, all the way up until you build the GPU-enabled components at the top. So we're having a lot of rebuilds of the same things for each stack. So we want to fix that. So introduce common stacks, enabled by a very cool feature called include concrete, where you can include a concrete environment and get reuse from those specs. And this allows us to go from this flat structure to this sort of DAG structure of stacks, where each includes the previous, we run them, and they only build the things that are unique to them. Right now, all of our stacks have their own build cache. So this is problematic because now that build cache no longer has the dependencies for the top level packages. There's this giant hole in the bottom. So to fix that, don't have multiple build caches. And we can project views into these with these build cache index views. So this is a feature in progress right now, now that we have the content addressed build cache v3 and merged. This fixes a bunch of race conditions with pruning as well. We won't get into that. But this will enable us to have these common stacks in CI. All right, so the last part of this, I'm going to go over the infrastructure that underlies all of this. So in the early days, it was all AWS everything. We used a lot of AWS console to spin up services, the autoscaler there, have our S3 build cache, all of the runners, and the Spack CI bridge, which would synchronize from GitHub to GitLab to run the pipelines on MRs and develop. This was fine, but we wanted to have this be more reproducible and spin up new clusters. So we switched to Terraform and Kubernetes. So now we can spin up the base of our infrastructure and then set up all the services on top and use Carpenter to autoscale efficiently. We also added on-prem runners. UO is currently providing a bunch of additional dimensions. There's a link down here for all of the things at the Frank cluster. And then how we do runner registration as well. If anyone else wants to contribute more runners, always looking for more. And so this gets really complicated now, right? When you run Kubernetes, now you have 2 problems. And so we need to keep an eye on all this and understand what's going on. And so we have this analytics database which goes and scrapes from many, many sources in the infrastructure, associates everything together, computes the metadata, and now we have a way to ask questions about what's going on. The most important question is, how many errors are we having in the cluster, and are they the infrastructure's fault? And so if you look at the plot in the left here with the blue lines, you see there's a really big blue block and a really small, tiny blue block. The tiny one is the errors, and then those errors are expanded above there on the different types. Most of those are build errors these days, which is great, because that's not our fault. So this is where we were, and this is where we are now, so it's quite a bit more complicated. And so we have Terraform, and now we can deploy things in a staging environment without breaking production. And so this is really nice. And so from this whole infrastructure and staging, we're able to sort of test things in the scope of these services here. So the build cache is separate, doing things in GitLab, the runners that we have there, that sort of thing. So just quick mention some of the cool things that are coming. So we're looking to incorporate Hubcast. Need to figure out how to do different pipelines with Hubcast. But this gives us cool things like user mapping, and it's an event-driven app, so it'd be a little bit more responsive. As well as dynamic mapping. So Krattiger's got a great talk later, so stick around, check that out, about gantry. And this is basically taking all of this analytic data that we have, we've collected in the infrastructure, and using that to make smarter decisions about what we're doing for allocations. And so here's sort of a future look at what we'll have. So more on-prem runners, Hubcast, a bigger analytics database, gantry, and all that good stuff. And so I could make this talk much, much longer. If you guys want to stick around, talk to me later. Here are the things that I did not cover, and this is not a complete list either. These are just things that I thought of in my room last night. And thanks to everyone who's been a part of making Spack CI a success.
Okay, so let's thank Ryan. This is a bit of a crash course, but I hope this makes it clear that there's a lot of stuff that goes on behind the scenes to keep the Spack ecosystem working. And this is sort of the really high-level overview of it, even though it might not seem like it. So I think we have time for one question, and then we'll go to lunch. Who wants to do the question? No one? No questions? Okay, one question.
Okay, this is kind of a crossover question with John Parent's presentation, but what does your CI look for, like Windows GPU support, if that's like a test that you can do? Or
Windows GPU?
Yeah.
We build against OpenGL with Wiggle.
Okay, and then but do you ever run the tests, or?
Yeah, I don't think, do we? Yeah, okay, yeah.
Okay.
Yeah, we do. I wasn't sure if they were working.
All right, so we'll see you all back here after lunch, and we've got a whole bunch of other talks on collaborations and then the lightning talks. So thanks for coming.